This strange-looking snake is known as Cerastes cerastes, or the Saharan horned viper.
So something that occurred to me while I was watching JC's video about the consequences of getting bit by one of these horned vipers is that I don't fully understand the evolution of horns in snakes and lizards. I had always assumed that they were anti-predator defenses. Having horns literally makes you tougher prey, but it turns out recent research suggests that the selective pressure underlying the evolution of horns in lizards and snakes is actually camouflage for sit-and-wait predators. Check this out. So this paper from 2023 investigated the relationship between foraging mode of snakes and lizards, specifically whether or not they are active hunters that pursue their prey, or whether they're ambush predators that wait for their prey to come to them, and the presence or absence of horns on the head. And what they found was that first, horns on the head have evolved independently, that is convergently, multiple times in the lizards and snakes. And you can see that represented in this really cool phylogeny. Anywhere where you see branches shaded in yellow, those are species that have horns on their heads. And then the researchers asked, well, what is it about these species that makes them stand out, if anything, compared to species that don't have horns on their heads? And so we're going to look at this little inset of the figure here. And what they found was that in hornless lizards and snakes, the likelihood that you're going to be an active predator versus a sit-and-wait predator is about 50%. But when they looked at those two foraging modes in the horned species of lizards and snakes, more than 94% of the horned species are sit-and-wait predators. So what are the benefits of having horns if you're a sit-and-wait predator, or conversely, what are the costs of having horns on your head if you're an active predator? And what the researchers suggest is that lizards and snakes that are sit-and-wait predators could use horns and other protuberances on their heads to break up the outline of the head. In other words, camouflage, making it less likely the prey detects the predator sitting and waiting in the foliage. On the other hand, if you're an active hunter, having horns just means you have these things sticking out of your head that can catch on foliage, that could get the attention of the prey. It literally makes you more conspicuous as opposed to less if you're moving through the environment. Now, despite the fact that that research strongly supports the hypothesis that horns on the heads of lizards and snakes evolved to camouflage sit-and-wait predators, does not preclude the operation or the function of those horns in other contexts. For example, in some species, males will use their horns to compete with one another, to throw rivals off a branch when competing for a female. And I think it would be impossible to argue that horns, even if they evolved in the context of camouflage, don't play some role in anti-predator defenses.